Napatech is about 5 years old, and we've established ourselves as a leader in the provisioning of Ethernet network adapters for intelligent real-time network analysis and forensics in general. So we've had a number of adapters out at 1 gigabit per second and 10 gigabit per second, and we're actually using a lot of different applications, from network monitoring analysis, network test and measurement, and a lot of network security applications, which is why we're here today. But what we're finding is that there are a lot of applications now where you have to capture data at full line rate. So if we're working at 10 gigabits per second, we need to capture all of the data that's coming in at 10 gigabits per second. So in the context of this show, there are a number of applications like intrusion detection and intrusion prevention systems, and also unified threat management systems or firewalls, which have to work in 10 gigabit per second networks and have the ability to capture all of that data and do some analysis on it, and maybe even retransmit that data again. So what our network adapters do is ensure that you can do that at full line rate. Even though it might seem like there's a lot of solutions out there that are working at 10 gigabits per second, if they're based on some of the standard network adapters that are on the market, they're probably only getting about 60% throughput on those cards. Now, what we've done is we've ensured that the design of our card will allow you to get 100% throughput on there. You won't lose any packets. And we've also brought a lot of the intelligence that would normally be in the application onto the card itself. So we do a lot of filtering on the card, deduplication, we do some timestamping on the card. So a lot of the intelligence that would normally be in the application and in software is now actually on the card. But what it means is that some of the work that the CPU, the central processing unit in the server, would be doing, just handling traffic, has now been moved onto the card. Now, up to now, if you're working at lower bit rates, it hasn't been a problem. But when you start moving into 10 gigabits per second, it becomes a real issue. If you want to handle all traffic for all packet sizes at 10 gigabits per second, you actually have to use a full CPU core to do that. The solution we have actually bypasses a lot of the things which would introduce today, so that the CPU is actually using only 1% of its power handling the traffic. That's the benefit of moving it into the actual adapter itself. So for example, normally you would ask a CPU, you would interrupt it and say, I have traffic on the adapter, please come and copy it into your memory. Well, in our design, we do that for the CPU. We copy it directly into the memory, we bypass the operating system, which can be the source of a lot of delay, and we just say to the CPU, it's already there, please work on it. Well, once people come around and we start to tell them our story, they are used to the standard adapters, so they realize some of the limitations. When we show them what we can actually do with our demonstrations and whatever, they really begin to become excited, because then they begin to see that some of the limitations that they have had in the past, they're no longer there. So new possibilities open for them. So in the end of the day, the benefit we're bringing is it actually accelerates the applications that are running there, and some of the blockages that they had in their pipes are suddenly gone, because now we're taking more of the load away from them. So that's the basic benefit we're bringing. There's a number of end users here, obviously, and we've been talking to a lot of those, and they come from a lot of different environments, a lot of different enterprises, banking backgrounds, financial backgrounds. Network security is now an issue that influences everybody. So I think everyone is aware that they need to have some solutions to deal with this. So we've talked to a lot of end users about that. Our main focus are the people who actually build the appliances. So we're selling to the guys who would make the intrusion prevention systems, or the detection systems, or the firewalls. And a lot of these guys are here at this show also exhibiting, but they have a chance to come around and talk to us also. And it's been quite a surprise for many of them to see us here. It's our first time here, and I'm surprised to see what we can do. Up to now, many people took it as given that you couldn't achieve more than 60% throughput on this. Now we're beginning to show them that that's not necessarily true. And they're beginning to get excited because now they can see new possibilities for their applications. So it's been very successful for us this year. Now, actually, one of the first markets we were very active in was in the US. So we've had a good presence in the US for almost the beginning. We have offices in Mountain View, we have offices in Andover, in Massachusetts. So we have a lot of our business in the US, and sometimes often known as a US company. And we have our base of operations in Denmark. A lot of the intelligence of the design and the development is from there. But we do have a good global presence, if you would, and we have clients all over the world. But definitely US and Europe is some of our major markets. In the area of network monitoring and analysis, we have a very good pedigree. We have a very firm customer base. We're moving into some other areas now for like inline applications, where we're moving into that more, where there's a need for both capturing and transmitting at full line rates. We're seeing more demands for that, and we're responding to that. Coming into more financial trading systems, etc. So there is a lot of applications for this technology going forward as we're beginning to use higher speed networks in a lot of different areas, and there are more niche applications being developed to handle different problems. Absolutely. I mean, one of the things that we provide in the card is time stamping, for example, with nanosecond precision. That's not something you get on a normal card. So if you want to do latency measurements in your network, well, you have to have this technology, and you don't have it any other way today. So that's something that we are actually enabling. But also just the ability to take all the packets in. For some applications, you don't want to lose any packets, and you want to do that for all packet sizes. That's a problem for standard cards today. If they get overloaded, they don't have any buffer memory, so if there's a burst of data coming into the card, they simply drop the packets. No, I don't think so. I think basically where you see our adapter being used is in applications where you need to run real-time at full line rate. That's where you'll see our application being used. There are lots of applications where you don't need that. If you're further out in the network, closer to the end user, then you won't be running at very high speeds out there. But once you get into the core of the network, where you have the very large and high speed rate connections, then you will need a solution like ours. So to put it short, we're not trying to put Intel out of business. I think we're going to be a very niche application in their world. But there is a demand for what we're trying to do for some of those very specific applications, like the kind of security applications I was talking about earlier. We're continuing to work on the adapters and the cards. We're going to be improving on those, and our customers are demanding new features all the time. As I said, we're moving into new application areas. There's new types of appliances being made every day, so there are new demands, new features that they want to see on the card, hardware accelerated. So we'll be working on that. The actual interfaces on the servers are starting to move into their next generations. We have PCI Express on our cards. There's a second generation of that coming along. There's new server architectures. There's new server chips coming along. We have to follow those. But the most important thing that's probably going to happen in the future is the move from 10 gigabits per second to 40 gigabits per second and 100 gigabits per second. We're seeing demands for that already from a lot of different applications, and we're going to be following that. And that's, if we're interested in a 10 gigabits per second application, we're even more interested in 40 and 100, where the problem is going to be extremely pronounced.